All right, and there we go, we're recording. Okay, a quick study session today. We are in finals week, and oh my goodness, that went fast. I wanted to do a couple of things today. First, I wanted to talk about a specific trick that you can do to make menu items in a list perform a lot more robustly. So we're going to take care of that. And yes, it's on the final. That's why we're talking about it today. And then I'll just really open it up for questions and see what kind of questions that you might have, or if we need to do some coding, we can do that. So let's start first of all with this problem. Okay, so I'm going to first go back to the iPad here. Get our little whiteboard. Hope you all enjoyed my masterpiece. It really is something. Okay, here's a problem. Okay, let's suppose that we've got a vector. Okay, so here's a vector. It's got some data in it. Okay, and let's suppose that the data that our vector has is just a bunch of objects. So the objects will contain, a bunch of data, right? This is vector element 0, 1, 2, 3, and on to, n, or n minus 1, I should say. And let's suppose that there is a vector or a class element in here that's a Boolean. Okay, so let's just say that we've got a bool here. I'm going to just call it in our case here. I'm going to just call it checked out. Okay, and here's what we're going for. Let's say that our vector is filled with objects, and these objects are of type, let's say movie. Okay, movie meaning you go to a store and you can go and rent a movie. Okay, well, all of these objects would be in this vector. This vector would kind of contain the store's inventory, and we can craft this class however we want, however robust we need it. But one of the elements in it is a Boolean that's called checked out. Okay, so let's suppose that checked out for our first element is false. The second one is true. Third, false. Fourth, false. And fifth, true. Okay, hopefully everyone's tracking still so far. Everyone's still tracking with what we're trying to go for here? All right. Let's then also suppose that one of the fields, is just the movie's name, right? So, there'll be a string name in here. And then we can say, all right, let's suppose the first movie is going to be Police Academy. That amazing 1980s era film. And it's not a movie, it's a film. There's a difference. And it was amazing. And then let's do the next movie will be Police Academy 2. And then Police Academy 3, Police Academy 4, and Police Academy 5. Okay. So now here's the challenge. Here's why we're going through this little exercise today. And that is, okay, given this is the data structure we're dealing with, it's a vector of objects of class movie or video, whatever you want to do it. We want to come out with a way to output all of the movies that are checked out. And we want to list them in an intelligent way. Now, we could easily just go through this and ask, okay, well, if that Boolean value is true, then we're simply going to output that list. So if we were to output, just do some light coding and get this, we could very easily output And you know what? I'm going to change one more value just so we have 3 values. So I'm going to change this one to true. Okay. So we could easily have output that would look like this then. 1 is Police Academy 2. And then here, the next data element that is true in that dimension is index number 3. And that's going to be Police Academy 4. And then the last one is going to be at index 4, Police Academy 5. Okay? And let's say that this goes on and on and on. You know, there's a bunch of movies here. So if we wanted to have our code just output a list of the movies that are checked out, that's how we could do it. We could list out the index number. So this is the vector index number here, 1, 3, and I'll call this 4 just for clarity, 1, 3, and 4. And that's where we get these numbers here, 1, 3, and 4. Okay, that's easy coding. This is kind of level 165 coding. Okay, the problem is, let's say that we're giving the user some choices here. For example, if a movie is checked out, let's say that you're writing a program that is going to manage the video store, and one of the options is, well, you got to check in the videos that are checked out. So if you have a check-in menu, you know, this might appear for that menu. You know, let's list all of them that are checked out, and then you can just go and pick the one that the customer is bringing back and that you're checking back in. Okay. So here, then, you know, they could pick 1, they could pick 3, they could pick 4. However, here is the issue that I wanted to address today. And it's this issue right here. If we gave the user a list of movies and we tell them, okay, go ahead and pick your movie. If we coded 1, 3, and 4, that'd be really bad. I mean, that's just not good interface design. It's not a good customer experience. Right away, they're going to think, well, where's movie number 2? Or where's movie number 5 or 6? You know, non-sequential numbering like this is just not good coding, not a good practice. Instead, we want to have our output not look like that, but we want it to look like this. You can pick 1 for Police Academy 2. You can pick 2 for Police Academy 4, or you can pick 3 for Police Academy 5. So our question becomes then, how do we code this? How do we code it such that when we list these numbers over here, we're just giving a nice sequential list rather than just simply regurgitating the vector's index that is associated with that movie. So here's where you come in. All right, so it's time to unmute yourselves, and it's time, if you're gonna, if you have an idea here, please go ahead and activate your video. I'd love to see everybody. And let's kind of brainstorm, how would we possibly code this? And it's tough because there's no easy mapping of these data elements. In other words, 1 does not map necessarily. 1 doesn't map to 1, 3 doesn't map to 2, and 4 doesn't map to 3 at all. And the problem with that is that you'd never have a reliable mapping because any of these Boolean variables could change at any time. So here's the question then. How could we go about coding this such that we get a numerical submenu of these movies that would be to be checked in? So what are your ideas?
We stuff in a new vector?
Stuff in a new vector. Okay, let's write that down. Stuff. And Jeff, I love that official computer science term that you used, stuff in a new vector.
Okay.
I was gonna say make a new vector and then do a for loop, and then if it's like equal to like a for loop that steps through the original vector and compares if they have like the same string value.
All right, sounds good. So we would kind of do the same thing that Jeff said. If we did a new vector and we stuffed in the right values, well, then we might be onto something. Other ideas?
Could we do like the thing from before where we did like a key and a map, and could we create like the number one like maps to this string, or no?
Do you know what? It'd be dangerous to try and come up with a map or a legend, because if any of those Boolean variables up in the vector, if any of those change, well, suddenly your mapping is off.
Okay, got it.
Yep. All right. So, was there one more idea there?
Yeah, can we use, say, a temporary vector and we only put in the true instances of the original vector into it?
There we go. Yep. So I think we're all onto something. That's the third great suggestion for, well, what if we just created a new vector that would contain, just, the data that we need, and we could just push into it any of the movies that are checked out. So that's the approach we're going to do. That is going to be the approach. So to review this, here's our original vector. And I'll do a whole bunch here just for clarity. And then let's say in this vector, those data fields that were in question, let's say that this one is false, it's not checked out. This one's true, this one's false, false, true, true, false. So our question here then is, here's the original vector with those true and false values. Then, what do we do? Well, let's just go through it. We can just iterate through that vector, and anytime we find a true value, let's just push that into a new vector. And what we would do is we would push the index number. We would push 1 into it, and then we would push 4, and we would then push 5. So if we had a new vector here, and those data elements are going to be, the indexes are going to be 0, 1, and 2 here, the data that they actually would contain are just integers. And we would push a 1 in, we would push a 4 in, and a 5 in. So now suddenly we have a new vector with 3 data elements, just integers, 1, 4, and 5. And of course, then the index numbers for those, are just like we've listed here. Regular vector there. So this is our I, and then this is the data. Well, now suddenly we have a way to map 1, 4, and 5 to 0, 1, and 2. So if we then were to just output these 0, 1, and a 2, we know that, well, element 0 contains a 1. So if we just then pulled the number 1 element, video name here, if we just pulled that over to here and output, that video name, and then here and here, well, then we're onto something. And then, oh, by the way, we don't want to present a submenu for our users saying, or starting to count at 0. I mean, who starts counting at 0? Yeah, or human minds start counting at 1. So we can change these. We just correct for the off by 1 error and, just add 1. And suddenly we now have this way of mapping and sort of collecting all of the true values, and then we can go and manipulate it. Now it's important though that here in this area, when we try and output the name, we know what the index is. It's index, number 1, because 1 is associated with this here. So we would then just go and we could count, movies, sub 1, and then dot, get name. And that's the way we could then get that movie. And so forth and so forth. So this is the little technique that I wanted to kind of go over. Now I've got some code that demonstrates this, and I'm also then going to I'm going to post that code, so you'll have it as a resource for you while while you're doing your final. So here is some code. Let's go through it very, very slowly and carefully. And what I'm going to do is sort of really space these things out, just so we look at one segment of the code at a time. Okay. So we start, and I'm on cloud 9 here. Let me see if I can zoom in just the slightest bit more. That might be a little better readability wise. Okay. All right. So here I'm just doing a single flat file. Amazon Cloud 9, it doesn't yet support, or at least last time I checked, it doesn't support multi-file projects in C++. So you have to just make it a flat file, a single file with all of your class declarations, implementations, and then the main program in it. All right, so here is a class, I'm calling it video. The private member variables, yep, a video is going to have a name. And then here's that Boolean value for if it's checked out or not, okay? Okay. These are our public methods. First of all, a very typical developed constructor. It takes a string and a Boolean, and then we just initialize those. Then a couple of accessors here get the checked out Boolean value, and it's going to return that, and then get the name of the movie and return that. Okay, so we're all good here on the class declaration and implementation. Very, very simple. And then you can probably see where we're going. We're going to create a vector of video objects. Okay? All right. Let me scroll down a little bit more. And again, I'm going to really space this out. So we're just looking at one block of code at a time. Okay. All right. So here in my main program, I've got a vector that's called collection. It's my video collection. Maybe yours is called collection also. Maybe it's inventory. Maybe it's store, whatever you want. And here I'm just going to push back 7 movies into it. Police Academy, and then the successor, the sequel, Police Academy 2, was even more amazing than Police Academy 1. And I can say that about every single successor. So here's our 7 Police Academy movies. And you'll notice that when we did create these objects, that I am passing the if they're checked out or not Boolean value. So here, Police Academy 2 has a true, so it's checked out, along with 5 and 6. So let's just remember that. Police Academy 2, 5, and 6 are the ones that are checked out. So our goal is we want to present a list to the video store clerk saying, all right, here's the movies that are checked out. Which one do you want to check in? Pick 1, 2, or 3. We wouldn't want to tell them pick 1, 4, or 5 because that's the bad user experience. Okay, so there's our starting data population code. That's that code block, okay? All right, here's just another little code block that is simply going to list out the movie along with their vector index. Okay, nice and simple. So I'm going to run this, and we'll see here in the very first set of output, this is just where we output the vector index starting with 0, so 0 to 6. I also output the title of the movie, and then just a quick blurb if it's checked out or not. Okay, so that's just iterating through a vector, and we can pull that data. Easy peasy. All right, now here's our next thing. And that is that I simply wanted to get a list of checked out movies. So we can do that. We just iterate through the vector. And if the collection sub I dot get checked out method, if that returns a true, well, then I'm going to output it. I'll output the index here. So this is going to print out I. And then here, this prints out the name, collection sub I dot get name method. You know, remember we are dealing with classes, so we've got to use our accessors. And then a quick end line. All right, so now what this gives us, let me run it again. What this then gives us is the list of checked out movies. I'll go back to the output here. And here now is our list of checked out movies. So if we presented this to the clerk saying, select 1 for Police Academy 2, 4 for Police Academy 5, that's the bad user design. No. Instead, we want this. We want sequential numbering. So we've got to change this. We're going to use that method that we just demoed in that we're going to create a separate vector and push in the index numbers of the movies that are checked out. So let's look at that code. Okay, I'll bring this over. And then here is the next little code block. All right, I am creating a vector. And remember, the only thing this vector needs to store is the index number in the original vector of the checked out movie. So it's an integer vector. It's not a vector made up of videos. Nope, let's simplify it. It's just an integer vector. And here, this code now is just, first of all, it's going to step through our collection vector. So from 0 to collection.size. It's asking, okay, well, if that object has the get checked out Boolean that returns a true, then I'm going to push I into the new checked out vector. I'm going to just push the index I. So what this does for us is then it's just going to stuff those values into the vector. And let's look at the output here. And this is it. Here I'm just outputting the new vector that we just created. And sure enough, it's showing that these are the 3 elements in that vector. And it's index 1, 4, and 5. And if we go up here to our original index data dump, we can see that, yep, it's index 1, 4, and 5 that are checked out. All right, and then here I just want to do a simple list of which videos are checked out. So this was the that one little line that's going to print out a 1, a 4, and a 5. So we're just going to iterate now through the checked out vector and just simply output the data that it holds. Not its index number, of course, but the data that it holds. So checked out sub I is the data that it holds. Okay. Now we want to map this so we can get that sequential numbering. So here's what we're going to do. We'll go through the for loop. This is the for loop of the checked out ones. And remember that the data that contains is a 1, a 4, and a 5. So the first thing I'll do here is we'll just simply output I. So I is going to be 0, and then a 1, and then a 2. And then look at this monster right here, okay? First of all, before we freak out, let's remember that we need to get some index here, collection sub something dot get name. So the question is, what is that something? Well, that something is checked out sub I. So this is sort of an instance of layered or nested indices, and it's going to do the job that we're trying to code, and it's going to do the job that we're demanding. Got to remember, checked out sub I is going to return either a 1, a 4, or a 5. So that 1 then replaces all that's highlighted, and it just becomes then collection sub 1 dot get name. and that's going to give us the name at that index in the original collection vector, okay? In the original collection vector. So let's look at the output again when we say, okay, now we map these for sequential numbering, and now suddenly we've got at index 0, we can go ahead and retrieve Police Academy 2, and then Police Academy 5, and Police Academy 6. Of course, the index numbers are 0, 1, and 2, so we're almost there. We need to just correct the off by 1 error and make those a 1, 2, or 3 now, just so that, you know, we can actually use them. So here, this code block now is going to just correct the off by 1 error. And it is doing the exact same thing that we did before, except in just the output only, we're going to add 1 to I, so that the output's going to be 1, 2, 3. I hasn't changed, so we still have that same code here of collection sub checkout sub I dot get name. So then when we look at our output again, the part where we correct for the off by 1 error, you see, there we go. That's exactly the output that we wanted to present the user, okay? Exactly the output that we wanted. Now that I put some comments in here, and you'll be able to have access to this, of course. And at this point, you know, just have the user enter a 1 or 2 or a 3. Make sure that you decrement it, so we correct for the off by 1 error. So now input would be a 0, a 1, or a 2. And all you need to do then is to call collection sub checked out sub input and call whatever appropriate accessor method, and appropriate accessor, and that's going to then pull the name or whatever other data that you might need. All right, so that's just a quick primer on something that you will see in the final, and I wanted to be Mr. Super Nice Professor Guy and give you a little primer on a good way to go about doing that. Now, is this the only way to do that? Nope, you could probably code this in multiple fashions, but in my mind, this is the one that's kind of the most direct and uses the least coding, and it just uses indexes that we already have and that we don't have to try and machinate. Okay, so that is what that is. And let me now just kind of open it up for questions. Any questions about anything?
Professor, I'm here late. Can you show me that code?
Yes.
Okay, thank you.
And then Jeff, this is also going to be, I'm going to post this code also in Canvas. So
Okay.
you'll have it.
Okay, thank you.
But it's fairly straightforward code. It starts with, no, here's our class. Here I'm going to create a bunch of objects and push those into a vector, and then so on from there. But you'll see the whole thing there, Jeff, when
Okay, no
when
problem. Thank you.
Good. You're quite welcome.
Thank you.
Any other questions? How are you all doing?
I have a 2 course. Will end up the same day. I have a 2 tests.
Oh, you have a final, another final on Thursday?
Yeah.
Same.
Yeah.
How miserable. How miserable is that?
Yeah. Mm.
Yep, that's a typical problem, and with short summer sessions like this, it's almost unavoidable. I mean, most, you know, if we were meeting in person, it'd be either a Monday, Wednesday, or a Tuesday, Thursday. So that means all of your finals are either going to be a Wednesday or a Thursday, and that's, yeah, that kind of stinks. in my regular semesters, I try and have the final earlier in the week. And that just hopefully avoids this this final exam overload in the last day of the semester. So, all right. Any other questions, y'all? All right, then I'm going to stop the recording here. Bye.